There is a sound that Uranus makes. Scientists discovered it in 2017, a low, haunting whistle buried inside data that Voyager 2 collected over 30 years earlier. It was just sitting there, waiting to be heard. A planet singing quietly to itself, billions of kilometers away, in the dark. Beautiful, right? Now, here is the contradiction that should stop you cold. We have sent probes to the sun. We have landed on asteroids hurtling through space at 90,000 kilometers per hour. We have placed rovers on Mars and kept them running for decades. We once dropped a probe into the atmosphere of Jupiter, the largest, most violent storm system in the solar system, and it survived for 58 minutes before it was crushed. But Uranus? We have never once attempted to go there. Not a lander, not an orbiter, not a single dedicated mission in the entire history of human spaceflight. One flyby in 1986, and then silence. Why? What is it about this pale blue world that makes the most powerful space agencies on Earth quietly, consistently look away? What are they not telling you? You probably first learned about Uranus in school. It was the seventh planet, the blue-green one. Maybe your teacher made a joke about the name. You moved on. But here is what no textbook ever told you, what makes Uranus fundamentally different from every other world we have tried to explore. Every planet in the outer solar system that we have studied up close, Jupiter, Saturn, Neptune, radiates more energy than it receives from the sun. They have hot, active cores churning with heat. That internal energy drives their weather, their storms, their magnetic fields. They are, in a sense, alive inside. Uranus is not. Uranus is the only giant planet in the solar system that radiates almost no internal heat at all. Its core temperature, estimated at around 4,700 degrees Celsius, sounds hot until you compare it to Jupiter, whose core burns at 24,000 degrees Celsius. Uranus is cold at its heart, silent, inert. And that single fact, a dead core, is the first link in a chain of consequences so extreme, so layered, so punishing that the planet has effectively made itself unreachable. Not difficult to reach, not expensive to reach, physically, functionally unreachable. Start at the top of the atmosphere, the first layer your spacecraft, or in this thought experiment, your body, encounters. The cloud tops of Uranus sit at approximately -220 degrees Celsius. That is not just cold, that is a number that requires context to even understand. The coldest temperature ever recorded on Earth's surface was -89 degrees Celsius at a Soviet research station in Antarctica. Scientists there had to wear special gear just to step outside for minutes. At -89 degrees Celsius, exposed skin freezes in under 30 seconds. Uranus is more than twice as cold as that. At -220 degrees Celsius, the air you breathe, oxygen, nitrogen, doesn't just become unbreathable, it becomes solid, a block of frozen gas, concrete made of atmosphere. But here's what makes it stranger. That dead core means the cold doesn't stop at the surface, it persists downward. Planets with active cores warm as you descend, pressure and heat rising together. Uranus barely does this. You descend into it expecting the temperature to climb, and instead it lingers, hostile and unmoving, far deeper than any physics should allow. Every material we use in spacecraft construction has a threshold. Below that threshold, metals become brittle, composites crack, seals fail, electronics die, not from a dramatic failure, but from a quiet cellular breakdown, atom by atom, as thermal energy is stripped away. The cold alone would end your mission, but the cold isn't even the second most dangerous thing about this planet. In 1992, Hurricane Andrew made landfall in South Florida. Sustained winds of 280 kilometers per hour. It was one of the costliest natural disasters in American history. It razed 63,000 homes. It scattered debris for miles in every direction. It reshaped coastlines. For days afterward, reporters walked through what remained and used one word, over and over, to describe what they saw: obliterated. The winds on Uranus reach 900 kilometers per hour. Not in a storm, not in a localized event, constantly, everywhere, pole to pole, equator to equator, 24 hours a day for billions of years. The entire atmosphere of Uranus is a single, continuous, supersonic river of frozen gas moving more than 3 times faster than the storm that obliterated southern Florida. To withstand winds like that, a probe needs mass. It needs reinforcement, armor. But the heavier the probe, the more fuel is needed to decelerate it into Uranus's orbit, which requires matching the planet's escape velocity. More fuel means more weight. More weight means more fuel. Engineers call this the tyranny of the rocket equation. It is a loop with no exit. Every calculation closes on itself, over budget, over mass, over failure. NASA has run these numbers. The math doesn't work, not with current propulsion, not even close. But even that isn't why no one comes back. In 1995, a probe called Galileo was dropped deliberately into Jupiter's atmosphere. It was not designed to survive. It was designed to last long enough to transmit data. It lasted 58 minutes. In those 58 minutes, Galileo sent back more data about Jupiter's atmosphere than we had gathered in centuries of observation from Earth. The pressure at the point of its destruction was calculated at around 22 times Earth's sea level pressure. Then its signal went dark. For Uranus, the planned probe would survive roughly 90 minutes. That mission, called the Uranus Orbiter and Probe, was ranked the #1 priority for large planetary science missions by NASA's 2023 Decadal Survey. The world's leading planetary scientists looked at every destination in the solar system and said, Uranus, that is the most important place we don't understand. The probe they're designing right now, not a crewed vehicle, not a rover, just a sensor package the size of a small car, is engineered to plunge into the atmosphere and transmit for 90 minutes before the pressure crushes it. 90 minutes. That is the entire window of contact. After that, nothing comes back. No data, no hardware, no record that it was ever there. The engineers who build it know this from the first sketch on the whiteboard. They are designing something specifically to die, quickly, meaningfully, in the atmosphere of a world we barely understand, alone, billions of kilometers from home. There is something quietly devastating about that. Now we need to talk about why Uranus is this way, because it was not always. Roughly 4 billion years ago, not long after the solar system formed, something hit Uranus, something enormous. An object estimated to be at least the size of Earth, possibly 2 Earth-sized bodies, struck the planet at an oblique angle with enough force to fundamentally alter its physics. It knocked Uranus onto its side. The planet now rotates at 97.77 degrees, nearly horizontal relative to its orbit. It does not spin like a top the way every other planet does. It rolls like a ball. One pole faces the sun directly for 42 years, then darkness. Then the other pole for another 42 years. Seasons that last half a human lifetime. And here is the twist that almost no one talks about. That collision likely created a shell, a layer of high-pressure water, methane, and ammonia, what scientists call a superionic ice mantle, which may have trapped the planet's internal heat and prevented it from escaping, not releasing it, trapping it. locking the core's warmth inside a compressed cage of exotic matter, while the outer atmosphere remained frozen and alien. The dead exterior may be a lie. There might be enormous heat locked inside this planet. Heat we cannot measure from the outside. Heat that a probe descending inward would encounter suddenly, catastrophically, with no warming. You would not just be crushed, you would be crushed and then incinerated in sequence. But let's say you survive all of that. The cold, the wind, the pressure, the hidden heat. Let's say some future version of technology keeps you intact, and you descend, and you reach something, some depth, and you want to leave. To escape Uranus's gravity from within its atmosphere, you need to reach an escape velocity of 21.3 kilometers per second. That is 76,680 kilometers per hour. For comparison, the Saturn V rocket, the most powerful machine ever built by human hands, lifted off at roughly 0.5 kilometers per second at the surface. It needed 160 seconds of maximum thrust just to clear its own launch tower. To leave Uranus, you would need to accelerate to 42 times that speed, from inside a pressurized, frozen, magnetically chaotic, potentially superheated alien atmosphere. You would need fuel, massive amounts of it. But here is the trap. You cannot bring enough fuel with you on the way down. The weight would make descent impossible. You would need to manufacture it in situ, from the atmosphere around you, using chemistry and hardware that does not exist yet, while that same atmosphere is actively trying to destroy you. You would need to build, from scratch, inside an alien ocean of frozen gas, a rocket powerful enough to punch through to open space. The physics does not permit it. Not today. Not with any technology on any drawing board anywhere on Earth. Every path into Uranus ends the same way. There is no path out. And yet, and this is the part that keeps scientists awake at night, Uranus might be the most scientifically important place in the entire solar system. In 2017, researchers at Lawrence Livermore Laboratory fired high-powered lasers at a material mimicking Uranus's mantle composition. What formed inside that compressed environment were diamonds. Actual diamonds, crystallizing under pressure in real time in a real laboratory. The models suggest that deep inside Uranus, diamonds may be raining downward through the mantle, centimeter-wide gemstones falling for thousands of kilometers through a sea of exotic, electrically conductive ice, settling on a core we have never seen and may never reach. But the diamonds are not the revelation. They are the distraction. What the interior of Uranus might actually contain is a physical state that barely exists in theory. Super-ionic water. Water in which the oxygen atoms lock into a crystal lattice while the hydrogen atoms flow freely through them like a liquid. A substance that is simultaneously solid and liquid. A state of matter that should not exist and does. Possibly in vast, ocean-sized quantities, pressed between the cold exterior and the buried, possibly burning core. We have one spacecraft's worth of data, from a flyby that lasted hours in 1986, to understand a planet hiding entirely new states of matter, diamond oceans, and the aftermath of a collision that happened before life existed on Earth. We know almost nothing. And what little we know is unlike anything else in the solar system. We name the planets. We put them on posters. We sell them as phone wallpapers. Beautiful, pastel, perfectly spaced, orbiting quietly in diagrams designed to make children feel like the solar system is a room they might someday walk through. But the solar system is not a room. It is not a neighborhood. It is a collection of processes so violent, so indifferent, so alien to everything we are built to survive that we have managed to set foot on exactly one of its bodies. One out of hundreds of thousands of known objects drifting in the dark around a single average star.
Uranus sings to itself in frequencies we cannot hear, hides matter that should not exist, and carries the scars of a catastrophe so ancient it predates every living thing that has ever drawn breath on this planet. It has been there, tumbling on its broken axis for 4 billion years. It will be there for 4 billion more. We will probably never go. We will almost certainly never return, and the universe, for its part, will not notice either way. That sound Uranus makes, that quiet, haunting whistle in the data, it was never meant for us. We just happened to be listening.